Hello my dear students, welcome to another video on inorganic semi-micro analysis, and this is the video number 6 on this inorganic semi-micro analysis where I'm going to discuss preliminary test for acid radicals, that is the dry test for acid radicals. Here, I will discuss the experiment and the reaction involved as well as the concept involved in the reaction. So, let's start. Analysis of acid radicals. And in this analysis, we divide into two parts. One is this dry test or preliminary test where the reagents are added directly to the dry salt or salt mixture. And the wet tests are generally confirmatory tests. Even few dry tests are also considered as confirmatory tests of the acid radicals. But in the wet test, we prepare the solution and the reagents are added to the solution of the salt. Now, so analysis of these acid radicals we are discussing. These acid radicals can be classified broadly into two groups. One is volatile group. Volatile group means which produces volatile products with acid or the evolution of gas with acid. Another one, non-volatile group, which do not produce any volatile product with acid or no evolution of gas with acid. Now for this volatile group, the principle is, of course, I'll discuss step by step in that experimental part. The principle is strong acid can release the weak acid from their salt. Based on this principle, these volatile group reactions are performed. Now, this volatile group, once again, it is divided into two subgroups. So, volatile group A, another one, volatile group B. The volatile group A means which produces the volatile products or evolution of gas with dilute acid, dilute sulfuric acid or dilute hydrochloric acid. Generally, we use the dilute sulfuric acid. And under this category, we have carbonate, nitrite, sulfide, thiosulfate, sulfide, and acetate radicals. And the subgroup B, that is volatile group B, it produces volatile products or evolution of gas with concentrated sulfuric acid. And under this group, we have acid radicals, fluoride, chloride, bromide, iodide, nitrate, oxalate, and tartrate. Now coming to the non-volatile group. Non-volatile group means which do not produce the gas with the acids. That means no volatile products. They are detected by the special test. And under this category, we will discuss about phosphate, sulfate, and borate. Now, coming to the dry test for the volatile group A, that means which produces volatile products with dilute sulfuric acid. We are using here dilute sulfuric acid. So, dry salt plus dilute sulfuric acid and then 1. See, if you get the colorless gas, that means evolution of colorless gas with Brix effervescence and which turns the lime water milky, then we can tell that it may be carbonate. Not generally you don't say it confirmatory, but this dry test is the confirmatory test for carbonate. Already I told you, few dry tests are also confirmatory tests. Then, if we get light brown gas with pungent smell and which turns acidified starch iodide solution blue, then it may be nitrite. if we get the gas with the smell of burning sulfur and which turns the acidified potassium dichromate paper green. That means you dip the paper in potassium dichromate and you just hold it over the gas. Then if this green spot, wherever potassium dichromate is there, if those spots become green, that means it may be sulfite. Then evolution of gas with the smell of rotten eggs, okay, and which makes this lead acetate paper. That means paper you dip it in lead acetate solution and hold over the gas, and then if you get the black spot wherever this lead acetate solution is there, then it is sulfide. Or you may do it in another way, dip it in the cadmium acetate solution and hold over the gas, then you will get the yellow precipitate. If you get the yellow spot wherever cadmium acetate solution is there, then it may be sulfide. Now, if we get the evolution of the colorless gas with the smell of vinegar and which turns the blue litmus red, then it may be acetate. And if we get the evolution of colorless gas with the smell of burning sulfur and a yellow precipitate is also formed, yellow precipitate or colloidal precipitate of sulfur is also formed, then it may be thiosulfate. Okay. Now one by one we'll see the reaction. So what I told, that evolution of colorless gas with bricks effervescence and which turns lime water milky, that in that case we can say maybe carbonate, and already I told you this is also the confirmatory test for carbonate. Okay. Now see, already I told you this test is based on the principle that strong acid can release weak acid from the salt. Here it is your sulfuric acid is stronger acid than carbonic acid. What happened? Say here you have taken the carbonate salt. Say it is sodium carbonate. Plus we have given this sulfuric acid. We'll get the bricks effervescence. Then what happened? Sulfuric acid is stronger, so it releases this carbonic acid. Sodium carbonate is the salt of carbonic acid. It releases the carbonic acid from the salt. And here another product you will get this sodium sulfate. And now this carbonic acid is unstable. Two OH groups are attached with carbon, so immediately water is removed, and that means as it is unstable, this carbonic acid, it is converted to anhydride of this carbonic acid, carbon dioxide and water. Right? Now this carbon dioxide, if you pass it to lime water means calcium hydroxide. You pass this gas to lime water, then what happens? It will become milky, turbidity will form. Why? Because here calcium carbonate is formed. It is just acid-base reaction. Carbon dioxide is acidic oxide. So calcium carbonate plus water. Now, if you pass more of carbon dioxide gas, then what will happen? Then this turbidity will go. That means solution becomes clear. Why? Because in that case, calcium bicarbonate will form. Now, this state, so here you get the turbidity with lime water, that is the test for carbonate. Same test, we can do it with baryta water, that is the nothing but the barium hydroxide solution. Here also same reaction, acid-base reaction, and here you will get the barium carbonate. This is also white precipitate. Both are white. White precipitate, white turbidity plus water. Okay, either you take lime water or you take baryta water. So this is the dry test for carbonate or preliminary test. But for carbonate, this is the confirmatory test also. Now another one, what we have seen, that light brown gas with pungent smell turns acidified starch iodide solution blue, then it may be nitrite. Okay. Here also the same principle, that is you take the salt of nitrite, okay, and this sulfuric acid. What will happen? The weak nitrous acid will be released. So it is HNO2 plus you'll have this sodium sulfate because the exchange of ions. So sodium sulfate, right? Now this nitrous acid decomposed HNO2, this weaker acid is released. Now this one will decompose and here we will get the NO, nitric oxide plus NO2 and then your water. Okay. So if NO is formed, then with real oxygen it is converted to NO2. So NO, NO2 plus water. Now here in the solution, here in that mixture, if you add this starch iodide solution, that means what is there in your test tube? Nitrous acid is there, plus you are adding iodide solution. Say potassium iodide, I am writing I minus iodide solution and in acid medium. Then what you will get? You will get the, here this iodide will be oxidized to iodine, right? And you will get this part, here you will get NO plus water. So here this nitrous acid will oxidize iodide to iodine. And iodine, we know, iodine with starch plus starch, it forms the deep blue color complex. That's why starch iodide solution we have taken. So it is deep blue complex. Deep blue complex will be formed, right? Then it is nitrite. Okay. Now coming to this one, if we get evolution of colorless gas with the smell of burning sulfur and yellow precipitate of sulfur, then it may be thiosulfate. Here also same principle. Say you take thiosulfate salt, say sodium thiosulfate, plus you have sulfuric acid which is stronger. So weaker acid is thiosulfuric acid will be released, H2S2 and O3, and here you will get the sodium sulfate. I'm writing only the important product. I'm not writing all the products. Okay. Now this thiosulfuric acid, what will happen? It will decompose to sulfurous acid, H2SO3 plus this sulfur. So this colloidal sulfur deposited which is yellow precipitate, right? And then this sulfurous acid, H2SO3, which is decomposed to sulfur dioxide. That's why you are getting the smell of burning sulfur. Gas with the smell of burning sulfur plus water. Okay. So here also what will happen? Weaker thiosulfuric acid is released. Thiosulfuric acid decomposed to sulfurous acid and sulfur. So we are getting the yellow colloidal precipitate of sulfur. And this sulfurous acid, this one, what will happen? It is decomposed to, it will form the anhydride of the sulfurous acid, that is sulfur dioxide, and then water. Okay. So what is the overall reaction? This thiosulfuric acid will cancel. Then sulfurous acid will cancel. So sodium thiosulfate plus sulfuric acid is equal to, means arrow, that is sodium sulfate, sulfur dioxide and water. Okay. So we are getting the burning smell of sulfur dioxide and also the colloidal sulfur, which is yellow color. Now coming to the next one, another observation was evolution of colorless gas with the smell of burning sulfur, which turns acidified potassium dichromate paper green, then it may be sulfite. Okay. So here what happened? If it is sulfite, you take the sulfite salt, Na2SO3 plus sulfuric acid, same principle, weaker acid will be released. That means we'll get the sulfurous acid and another product will be this sodium sulfate, Na2SO4. Right? Now what happened? This sulfurous acid, already what will happen? It will decompose H2SO3. It will decompose and form its anhydride, that is sulfur dioxide plus water. Right? And sulfur dioxide is reducing agent and potassium dichromate is oxidizing agent. So, if you dip the paper in potassium dichromate solution and hold over the gas, which gas is coming out? The sulfur dioxide, which is having the smell of burning sulfur. Then redox reaction will take place. So, what is the reaction? We have taken dichromate, Cr2O7, 2 minus, plus we have this reducing agent sulfur dioxide gas, and then it is in the acid medium. What will happen? Dichromate will oxidize this sulfur dioxide, that means anhydride of sulfurous acid. So it will form the sulfate. Okay, that means anhydride of sulfuric acid and itself reduced to chromium plus 3. Here it is chromium plus 6 state. Then it will be reduced by sulfur dioxide to chromium plus 3. So chromium here plus 3 plus this sulfate will form plus water. This is the equation. So that whenever you are dipping the paper and hold over this gas, which gas? Gas with the smell of burning sulfur, then that paper will become, wherever the dichromate solution is there, it will become green. That is the test for your sulfite. Now coming to the next one. Evolution of colorless gas with the smell of rotten eggs, which turn lead acetate paper black and cadmium acetate paper yellow. It may be sulfite. Again the same principle. You take this sulfite salt and this sulfuric acid. So weaker acid will come out. Weaker acid here is hydrogen sulfide, which is a weak acid, and here as usual sodium sulfate is formed. Right? Now this hydrogen sulfide, when you are, just what you are doing, you are dipping the paper in lead acetate solution and holding over the gas. The gas with the smell of rotten egg is coming out. You are holding over it. Then what happens? So it is lead acetate solution, CO whole 2 Pb. Then you will get the black precipitate of this lead sulfide. This is black. Plus here you will get the acetic acid, CH3COH. Okay. Then same thing, similar reaction, you can do it with the cadmium acetate paper. That is paper dipped in cadmium acetate solution. So it is CH3COO whole 2 cadmium. Then you will get the cadmium sulfide precipitate, which is yellow in color, and plus as usual this is acetic acid. So this is the test for sulfide. Now coming to the next one, what you have observed, that evolution of another one is evolution of colorless gas with the smell of vinegar, which turns moist blue litmus red. So here, and then it may be acetate. You can infer it may be acetate. So here, take the acetate salt, CH3COONA plus your sulfuric acid. Okay. Same thing, weaker acid will be released. That means acetic acid. This acetic acid will get the smell of vinegar. Smell of vinegar. Okay. And plus you will have this sodium sulfate. And as it is acetic acid is evolving, acid makes blue litmus red. Okay. Now coming to the dry test for this volatile group B. That means where we are using the concentrated sulfuric acid and 1 also. So first one, if you get evolution of pungent smelling gas that gives dense white fumes with a glass rod moistened with ammonium hydroxide solution, or evolution of greenish yellow gas when manganese dioxide is added, then it may be chloride. See the another one. If you get the pungent smelling reddish brown gas and this evolution of the gas is intensified when a pinch of manganese dioxide is added, then it may be bromide. You can infer it may be bromide. Then if you get the evolution of violet vapor and that evolution also intensified by the addition of pinch of manganese dioxide, then it may be iodide. Then evolution of pungent smelling white fumes, which makes the gelatinous precipitate when moistened glass rod is brought in contact with it. That means you will get the white fumes. Then you take one glass rod, you dip it in water, that means make it moisten and hold over that fumes, then you'll get the gelatinous precipitate. In that case, it may be fluoride. That is your inference. Another one, if you get evolution of colorless, odorless gas, which turns lime water milky and burns with blue flame. That means two gases. One is making lime water milky and another one is burning with the blue flame, and no charring of the content. The content does not become black. Then it may be oxalate. In the same situation, if the charring takes place, that means content become black and smell of burning or burnt sugar is found, then it may be the tartrate. Next, evolution of brown fumes which gets deepened. First is the evolution which become deep on addition of copper turnings and the content become blue. Then it may be nitrate. Okay. Then one by one we'll explain all these tests. So what we have observed? Evolution of pungent smelling gas that gives dense white fumes with a glass rod moistened with ammonium hydroxide, or evolution of greenish yellow gas when manganese dioxide is added. Then we can infer it may be chloride. So it is chloride salt. So you take sodium chloride plus this is your concentrated, this is volatile group B, concentrated sulfuric acid. Okay. And then what we are getting? Same thing, weak acid will come out. That means hydrogen chloride, and here it will be sodium bisulfate. Now, this hydrogen chloride gas, it is evolving, and what you have done, you have dipped one glass rod in ammonium hydroxide and hold over it. So, ammonium hydroxide, it will be just like acid-base reaction. Then what will be formed? Ammonium chloride will form, which gives the dense white fumes. Dense white fumes. Plus here water. Okay. Then it may be chloride. Another way what we are doing, we are adding this hydrochloric acid is formed. No, here we are adding this manganese dioxide, MnO2. Okay, so this one manganese dioxide, and then your sulfuric acid is also there. Then what is happening? We are getting this chlorine gas. What happens? Concentrated sulfuric acid is oxidizing agent, right? So it can oxidize this HCl, hydrochloric acid, to chlorine, but it is not so strong enough in this case to oxidize. If you get manganese, if you add manganese dioxide, then easily it will be oxidized in presence of sulfuric acid. And then what will happen? You will get the evolution of chlorine gas. This is greenish yellow. Greenish yellow. Okay. So what is the overall reaction? Overall reaction you see here, HCl is getting cancelled. This two overall means this is another one, this and this. Okay. See here, this HCl and this HCl is getting cancelled. So what is left over? Sodium chloride plus concentrated sulfuric acid. Okay. Then manganese dioxide. And this product is, what are the product? Product is this sodium bisulfate, chlorine, okay, and then you will get the manganese sulfate. Manganese will form with the manganese sulfate plus water. Try to understand. See, sodium chloride, concentrated sulfuric acid, HCl, and sodium bisulfate. Now we are adding little bit of manganese dioxide. So HCl is there, manganese dioxide is there, concentrated sulfuric acid is there. Okay, concentrated sulfuric acid also oxidizing agent. In presence of manganese dioxide, more vigorously oxidation takes place. So HCl will be oxidized to chlorine gas. Okay, and here manganese sulfate plus water will form. Okay, so what is the overall reaction? This reaction and this reaction, you just add it. So sodium chloride, concentrated sulfuric acid, this HCl getting cancelled. this manganese dioxide, and the product is sodium bisulfate, chlorine. This manganese will combine with sulfate, manganese sulfate, and water will be formed. Okay? And you'll get the greenish yellow gas, right? Now, similar way, if you get the evolution of pungent smelling reddish brown gas, and the gas evolution is intensified when a pinch of manganese dioxide is added, then it may be bromide. Similar thing. Here you are taking the bromide salt. Bromide plus concentrated sulfuric acid. Right? So here what you will get? You will get HBr plus NaHSO4, sodium bisulfate. Now HBr is little bit reddish brown, but if you add manganese dioxide, then hydrogen bromide plus this manganese dioxide, then what will happen? More vigorous oxidation will take place. Then bromine gas will evolve. This is your reddish brown gas. Okay. Plus here sulfuric acid is there, no? So manganese sulfate and water will be formed. So what will be the overall reaction? I'm not writing here. Look at here. HBr will get cancelled. So sodium bromide, sulfuric acid, manganese dioxide. Product is sodium bisulfate, bromine gas, which comes out as reddish brown gas. Manganese sulfate. This manganese will combine with sulfate ion and water. Now coming to the next one. If you get evolution of violet vapor, which is increased on addition of a pinch of manganese dioxide, just like chloride and bromide. But if you get violet vapor, it may be iodide. So similar things, you take iodide salt plus your concentrated H2SO4, then it will release this hydrogen iodide, weaker acid, plus as usual sodium bisulfate. Now here if you add little bit of manganese dioxide, then what will happen? And sulfuric acid is already there. Then what will happen? It will be oxidized easily to iodine, which will come out as violet vapor. This will become violet, plus this manganese sulfate, it will take the sulfate ion, plus your water. So what is the overall reaction? Overall reaction is this HI getting cancelled. So sodium iodide, concentrated sulfuric acid, manganese dioxide. The product is sodium bisulfate, iodine vapor, which is violet color, manganese sulfate plus water. Okay. Now coming to this nitrate. Okay. Here also same thing. What you have to do? Here you will get the brown fumes, and which will become more deep if you add copper turnings, and the content become blue. Okay. So here also take the nitrate salt, say sodium nitrate plus concentrated sulfuric acid. Then what happened? Sodium nitrate, concentrated sulfuric acid. As usual, here you will get the nitric acid, that is HNO3 plus your sodium bisulfate, NaHSO4. Now, this nitric acid how it reacts with copper turnings, nitric acid plus copper. Okay, it will form the copper nitrate, cupric nitrate, which is blue in color, plus your nitrogen dioxide gas. Okay, you will get the vapor of nitrogen dioxide and water. Actually, what happens here? So first, here nitric oxide will form and then it will be oxidized by oxygen to nitrogen dioxide. Right? So, but if you give the copper turnings, according to this reaction, nitrogen dioxide will form. Okay? Nitrogen dioxide will form and you'll get this brown vapors and this will become blue and this is your brown vapor. Brown vapor. So it is nitrate compound. Now coming to the next one. Evolution of pungent smelling white fumes makes gelatinous precipitate when moistened glass rod is brought in contact with it. It may be fluoride. What is that? That means that salt plus concentrated sulfuric acid. Okay, you are warming, heating, then you will get the pungent smelling white fumes. Okay, and then not only white fumes, you'll get some water droplet at the walls of the test tube also. And when you are just holding one moistened glass rod, that means glass rod dip in water, hold over the vapor, okay, then you will get one this gelatinous precipitate or white crust. Okay. Then it may be fluoride. Okay. What is happening here? Here, first of all, as usual, say, see, sodium fluoride I am taking plus here this concentrated sulfuric acid. Then it will form the HF, hydrogen fluoride, and here you will get the sodium sulfate. Here I will make 2 NF, and here 2 HF. This is the white fumes. This is a HF, hydrogen fluoride is a fuming acid, fuming gas. Okay. Now, this hydrogen fluoride, it condenses in contact with that moisture in the air and it deposited as water droplet at the walls of the test tube. Right? And moreover, what happened when you are holding this glass rod? Okay. First of all, you are doing in the test tube, that means made up of glass. Then what happened? Glass means silica is there. So this silica plus this hydrogen fluoride, it will form the silicon tetrafluoride. Okay, this vapors will form silicon tetrafluoride plus this water. Okay. So this vapor is coming, silicon tetrafluoride. Okay. Now on this, when you are holding the glass rod dipped in water, that means moisture, then what will happen? It will form the silicic acid. That means this silicon tetrafluoride plus your water, then you are getting first hexafluorosilicic acid, that is H2SiF6 plus this silicic acid, that is H4SiO4. This silicic acid is deposited. This is your silicic acid. It is deposited as this gelatinous precipitate or just like white crust. White crust. Okay. So coming to the next one, evolution of colorless, odorless gas turns lime water milky and burns with blue flame. That means two observations. Gas is burning with the blue flame and the coming out gas makes lime water milky and no charring of the content is clear, then it may be oxalate. Okay. See what is happening. We take oxalate salt, Na2C2O4, C2O4 plus your concentrated sulfuric acid. Then what we are getting, as usual, weaker acid will be released. That means oxalic acid plus it is sodium sulfate. Now what happened? This concentrated sulfuric acid is also a dehydrating agent. So what it will do? It will remove this oxygen hydrogen from this oxalic acid as water, and here carbon-carbon bond also breaks. Oxalic acid is this one, C. COH, COH. Okay. So oxygen hydrogen removed water and this bond also breaks. But in oxalic acid, carbon-oxygen ratio is 1:2. So sufficient oxygen is there after removal of hydrogen as with oxygen as water. Sufficient oxygen is there to oxidize all the carbon to carbon monoxide, and then carbon monoxide in aerial oxidation it will convert it to carbon dioxide. Even initially also some of the carbon oxidized to carbon monoxide, some of the carbon oxidized to carbon dioxide. Okay, and when the carbon monoxide burns with a blue flame in air, then automatically it is converted again to carbon dioxide, right? Okay, so no blackening or charring takes place. In that case, what is the reaction? That is oxalic acid plus this concentrated sulfuric acid is acting as dehydrating agent. Okay, and it is dehydrating. That means water will be formed plus this carbon dioxide and carbon monoxide. So it is carbon is oxidized to carbon dioxide gas, carbon monoxide gas and carbon dioxide gas. Okay, no carbon is left over. But in case of tartrate, say if we take the sodium potassium tartrate, sodium potassium, then C4, then H4, C4H4O6, sodium potassium tartrate. Okay, plus this concentrated sulfuric acid. As usual, first it will be tartaric acid. So then you will get C4H6 and then O6. This is your tartaric acid plus sodium sulfate will form, right? Now, in this tartaric acid, this carbon is to oxygen, this ratio is 1:1.5. So, not sufficient oxygen is there. Sulfuric acid, once again, it will dehydrate. Okay, water will be removed. But not enough oxygen is there so that all the carbon is oxidized to your carbon monoxide and carbon dioxide. Some of the carbon will be left over. So content become black. That means charring takes place, which does not occur in case of oxalate. Okay. And this carbon, it reduces this sulfuric acid to sulfur dioxide. That means sulfurous acid, and the oxide of sulfurous acid is sulfur dioxide. So, what reaction you will get? You will get this C4H6 O6 plus concentrated sulfuric acid. Okay. So here dehydration will take place. Dehydration will take place means water will form, and as I told you, carbon monoxide will form. Carbon will be oxidized to carbon monoxide and carbon dioxide. Carbon monoxide burns with blue flame. Carbon dioxide turns lime water milky. Okay. Plus what will happen? The carbon is not completely oxidized. That leftover carbon will reduce the sulfuric acid and it will form the sulfuric acid. Reduced means sulfurous acid. You'll get the oxide of sulfurous acid, that is sulfur dioxide plus other products. Okay, so this will be the observation for tartrate. Now coming to the dry test for non-volatile group. Okay. Non-volatile group, that means you have to identify them by special test. And here we'll discuss about phosphate and borate. For sulfate, in non-volatile group you have seen borate, phosphate and sulfate. Sulfate you have to prepare the solution, then only you can do the test. So we'll show it in the wet test. Okay. The first one is this one, phosphate test. To the dry salt mixture is boiled with concentrated nitric acid, and to this solution ammonium molybdate solution is added. So concentrated nitric acid and then ammonium molybdate, you will get the yellow precipitate, then phosphate is confirmed. So what is happening here? Here also same thing, you take any phosphate salt, say you take the sodium phosphate, Na3PO4 plus your concentrated nitric acid. So here phosphoric acid, weaker phosphoric acid will come out or will be released, H3PO4 plus it will become sodium nitrate. Then this phosphoric acid H3PO4, it reacts with ammonium molybdate, that is ammonium, I'm not balancing the equation, ammonium molybdate, this one. Then plus nitric acid is there already, okay, plus this nitric acid already there, okay, in the solution. Then what happened? It will form ammonium phosphomolybdate, one complex, that is insoluble heteropolyacid complex, and it will give the canary yellow precipitate. What is the formula? Formula is like this. This precipitate, this is canary yellow precipitate, okay, and this complex is it is insoluble heteropolyacid complex, plus here ammonium nitrate will form. So this is actually the confirmatory test for phosphate. Now coming to this one, which is the test for borate. Here what you have to do, in the salt mixture you have to take in the test tube, then you have to add concentrated sulfuric acid, and then you have to add the methyl alcohol. You heat it, the vapor will come out, then you ignite the vapor, you'll get the green edged flame, very nice green edged flame. Here also what is happening, you take the borate salt, say sodium borate, okay, plus what you have given? Concentrated sulfuric acid. Concentrated sulfuric acid, right? Now here, as usual, I told you boric acid will form. So H3BO3, this boric acid will form. Now I put one bifurcation. Now this boric acid, okay, with this methyl alcohol, it forms the ester. Okay, methyl trimethyl borate. So what is that? Boric acid plus this methanol or methyl hydroxide. Then what will get? Trimethyl borate. This ester CH3O whole 3B. Okay. This trimethyl borate ester is volatile. When you ignite the vapor, it burns with the green edged flame. So this is your ester. And what is this ester? Trimethyl borate. Trimethyl borate, right? Which burns as a green edged flame. Here you can use, in place of methyl alcohol, you can use the ethyl alcohol also. But better to use methyl alcohol because methanol is more volatile. You will get the vapor easily, which you will ignite and give the green edged flame. So this is all about the dry test of acid radicals of the volatile groups, non-volatile groups, and volatile groups. There are two subdivisions. All the tests we have discussed. Hope you have understood. Thank you.